Hi, I'm Caroline Reichmann, and today we're going to be doing a problem on rectilinear motion. The position function we'll be working with today is 3t cubed minus 19t squared plus 30t minus 8, and it's from the interval of 0 to 6 seconds. Here's a graph, and as you can see, the maximum is at 1.051, 6.025, and the minimum is at 3.171, negative 8.264. I've also showed the zeros on this position function. So one is at 1/3, there's another one at 2, and another one at 4. In order to keep track of these values without having to continue to write out the whole decimal, we'll be using A equals 1.0511768, C equals 6.0253883, B equals 3.1710429, and D equals negative 8.264071. So this will just make it easier to keep track later on. First, we'll be looking at question number 7 because this is the second part to a larger problem. If you want the first 6 questions, then look at Liana's video. But for now, question number 7, what is the particle's position when it is the furthest from the origin? First, you're going to test the endpoints. So since the interval is 0 to 6, you're going to test at 0 and 6. So you're going to plug in 0 into the position function, and that's going to give you negative 8 feet. And then you're going to plug in 6, and once you do that, you're going to get S of 6 is 136 feet. And then you're going to test the maximum and minimum. So first, when you test the position at the maximum, S of A equals C feet, and you know those values from the previous slide. And then you test at the minimum, and S of B is D feet. So ultimately, the particle is furthest at t equals 6 seconds when the position is 136 feet. The next question is, when does the particle hit the origin? For this problem, the particle hits the origin when S of t equals 0. So you're going to graph the position function on your calculator and find the zeros when S of t equals 0. But I've already done this for you, so on the graph you can see that when S of t equals 0, t equals 1/3 or 0.33 repeating, 2 and 4 seconds. Question number 9 is, at what time or times is the particle left of the origin? So for this, you're going to graph the position function on your calculator, and to determine when the particle is to the left, S of t must be less than 0. So the particle is to the left of the origin when the graph is below the x-axis. And as you can see on the graph here, the graph is below the x-axis from 0 to 1/3 or 2 to 4 seconds. And 0 is included in this because that's the original time. And for your final answer, you have to include that S of t is less than 0 because that's the explanation for the answer. Question number 10 is, at what time or times t does the particle move to the left? For this one, the particle moves to the left when S prime of t or V of t is less than 0. So using the position graph, you can find the times when the graph of S of t has a negative slope. And as you can see on the right here, I have the graph, and there's a negative slope from point A to point B. So the answer is A to B seconds since S prime of t is less than 0. The next question is, how far to the right has the particle moved? And for this one, you're going to add the absolute values of S of t at t equals 0, t equals A, t equals B, and t equals 6. So here I've included those values on the graph. And so you're going to do absolute value of S of 0, absolute value of S of C, absolute value of S of D. And S of D is important because that value is negative. So you must remember to take the absolute value so it's positive, and then you add 136. And the final answer is that the particle has moved 158.2894596 feet to the right. Question number 12 is, when does the particle stop? And the particle stops when the derivative equals 0. So the derivative equals 0 at the points of inflection, and these are at times A and B. So your answer is t equals A and B seconds, because S prime of A and S prime of B both equal 0. Question 13 is, when is the particle speeding up? And it's speeding up when the velocity and acceleration have the same sign. So in order to do this, you're going to graph S prime of t and S double prime of t onto your calculator, but I have a graph here on the right just for your convenience. And I have the velocity function, which is 9t squared minus 38t plus 30, and the acceleration function, which is 18t minus 38. And those are both graphed here. As you can see, since this is the velocity and acceleration function, it first hits the x-axis at time A, and that's when the velocity function becomes negative because it's below the x-axis, and the acceleration function is also negative at this point, but only until 19/9 seconds, which is about 2.11 repeating. Since those are both negative from A to 19/9 seconds, then that means that the particle is speeding up because S prime of t is less than 0 and S double prime of t is less than 0. And then at 19 9 seconds, the acceleration function becomes positive, but the velocity function is still negative. So until the velocity function reaches B seconds, the particle is not speeding up, because that is when velocity becomes positive. So from there until the end of the interval, which is 6, that's when the particle is speeding up again. So your answer here is B to 6 seconds, since S prime of t is greater than 0 and S double prime of t is greater than 0. And you have to have both of these. You have to consider both when S prime of t and S double prime of t are less than 0, and then also when S prime of t and S double prime of t are greater than 0. And the last question, number 14, is, what is the initial direction of the particle? For this problem, you must find S prime of 0. So you can plug in 0 into the velocity function, and when you do that, you get S prime of 0 equals 30 feet per second, and since this is greater than 0, the initial direction is to the right. And that is all. I hope you found this video helpful, and have a good summer, Mr. Hall.